Great, thank you everybody for sticking around. I'll try to be brief. My name is Clara Blum. I'm a PhD candidate at ETH Zürich and have the pleasure today to present the results of our recent study towards tracking circular construction supply chains, data carrier performance in realistic experiments. This research was conducted at the Lab for Circular Engineering and Architecture together with Jens Hunhevicz, Brandon Byers, and Catherine de Wolf. I'd like to start with an image of the space which the study was conducted in. Imagine accessing the storage space, and you have to select certain materials according to their properties and history. Well, this is easier said than done, but it's crucial in the context of circular economy driven by the reuse strategies and particular reuse. So I reiterate, whilst circular construction supply chains aim to mitigate environmental impacts of the construction sector, efficient reuse of materials requires tracking and tracing of materials and their data and robust data management solutions. Ensuring transparency and efficient decision-making across multiple stakeholders and phases requires a bridge between the physical and digital. A local solution on the material level is to facilitate seamless reading of material data by attaching physical data carriers to pieces of materials. These give access to the information, or more commonly to a link to the externally stored information. So there are different physical data carriers which exist, each with their own advantages and disadvantages. So you might ask, which type of carrier works best, under which conditions, and how do users experience them? Now that we established the relevance and the goal, I will briefly summarize a previous study, then move to the current experiment and present the results in comparison with the study to finally interpret and discuss these findings. So in a previous study by Byers et al., he compared direct product marking, quick response, and near-field communication for speed, error rate, and usability. Findings showed that DPM underperformed compared to QRs and NFCs, and users preferred NFCs. As this A encourages trends to increase data carrier digitization, and B, the former study was conducted in a controlled environment with the materials clearly spread out and the data carriers directly visible, we asked ourselves if increasing data digitization, here RFID and QR, show better reading efficiency than the traditional approach like DPMs. We shifted from NFC to RFID in the study. They both originate from the same technology, but RFID has a longer reading range and can scale multiple tags at once. So we wanted to test if this holds up in an uncontrolled practical condition. We also asked how an uncontrolled environment affects the effectiveness of data carriers compared to a controlled environment. So we returned to the setup of the current study. Consistent with this previous study was that the same diverse set of materials was used. Participants had to complete the same task of reading material passports and identifying components older than 25 years, and the same metrics were assessed, so task time, error rate, and usability. What changed was that the current experiment took place in an uncontrolled setting. Each participant had only one data carrier to test without observing other participants, and the participants completed the task only once, ensuring unbiased individual results. The data carriers were not always placed on the same side of the material types, but they were always in the line of sight of the participants to avoid any handling of the material. And before starting, the participants were informed how many components were tagged and what types of materials to expect. A facilitator timed each task and recorded the results, and then asked the participants to fill out the usability survey at the end. Statistical analysis focused on performance comparison of the former study and this study, and time and error rates were assessed in means and their advantages over DPM as a baseline, whilst the usability was compared in absolute values. So the system usability scale, short SAS, is a standardized survey that gives a score from 0 to 100, measuring how usable and user-friendly the system feels to the participants. So in the former study, time decreased by around 50% for QR and NFC compared to DPM, and in the current study we see a similar trend, of QR decreasing by 44 and RFID by 37 compared to DPM. So whilst both QR and RFID improved performance over DPM, QR remained the fastest, even in the uncontrolled environment. Whilst the former study had more errors occurred with QRs compared to DPMs, NFC outperformed both. And on the contrary, in the current study, we see close to no errors in DPM and QR, but some errors in reading RFID tags. This suggests that the complexity of the reader's setup of RFIDs introduced more variability. Participants in the former study strongly preferred QR over DPM and NFC over both of them. This reflects that more digital systems are generally easier and more pleasant to use. In the current study, we saw a similar trend, but QR was slightly preferred over RFID in this case, which suggests that both QR and RFID were well received, but QR remained the favorite. Distributions of the results were also visualized to support the interpretation of the current study only. DPMs are tightly clustered, confirming it was consistent but slow. QR times also were relatively close and faster, indicating both speed and reliability. RFID showed a greater variability with a broad spread, so the timing with RFID varied a bit more. DPM displayed a relatively wide range in error with few higher outliers, and QR showed no distribution here because there were no errors. It worked great. RFID again showed a broader spread. So DPM showed a wider spread in the sus with a concentration towards the lower end. So DPM does not rank well amongst user friendliness. QR, on the other hand, is tightly concentrated in a mid to high range score with a peak in highers, indicating a stronger consensus that it's user friendly. RFID had a wide spread clustered in the higher score, suggesting that the user experience with RFID is more context dependent and varying accordingly. So let's move to the discussion focusing on those two key points, the impact of the data carrier digitization and the impact of uncontrolled environments. We expected that more digitally advanced carriers like QR and RFID would perform better than traditional markings like DPM. That trend held largely true, but it's important to note that in the controlled study, performance improved clearly with digitization, but this pattern shifted in the uncontrolled setting slightly. RFID showed fewest errors, but had variable speed, pointing to technical potential limitations through handling or interference. So when we look at the impact of the environment, we saw the changes that across all carriers, reading times were slower in the uncontrolled setting, and QR remained highly usable, showing that it's robust, whilst RFID was less consistent. This underscores also the importance of testing user-centered design and real-world situations, because practical usability often matters more than just the technical sophistication. To briefly assess the limitations and the next steps, I like to point out that this exploratory study had a rather small sample size, so future research should increase this. RFID and NFC need also to be tested under the same conditions for a direct comparison, and real-world validation with industry partners is key for scaling this solution. So in short, future work should be larger, more comparative, and grounded in further practice. To conclude, the study extended prior work by testing RFID, QR, and DPM in more realistic settings, and key takeaways are, yes, digitization helps. Both QR and RFID performed better than DPM, but QR still outperformed RFID. So whilst RFID has potential, it depends on the context, like handling and environment. With this, I'd like to thank the participants of the study, also Jennifer Badnes and Roxanne Goldberg and Ball of Switzerland, and all of you for your time, and I'm happy for any questions and otherwise during lunch. Thank you.